Good morning, this is your Stats Sensei, Mr. Spensei, and this is an exit ticket on one sample proportions. And we're going to be looking back to the problem we did for the warm-up where the scenario was stealing Coke. In the warm-up, we actually ran the tests, but we never wrote our conclusion. So we're going to look back at that problems and we're going to write the conclusion. I'm going to read the scenario just as a refresher, and then we'll look back at what we did and we're going to write our conclusions and the parameter. So Slurp Shack is a hotspot for high schoolers and college students who crave oversized burgers and bottomless fries and self-serve drink stations. The restaurant's free water cup policy is meant to be a courtesy, but the manager, Mia Carter, suspects that too many customers are stretching the rules. Studies indicate that about 18% of customers, and this was our population claim, at self-serve beverage stations take soda after asking for a water cup. Mia believes the problem is worse at Slurp Shack. To test her suspicion, she collects a random sample of 85 customers. So there's our sample size from the population of 970 who requested a water cup, and finds that 24 of them helped themselves to soda. All right. At a significance level of 0.03, tests and managers claim that more than 18% of the customers at Slurp Shack are taking soda without paying. So the very first thing it asks us to do is define our parameter. Or what do we care about? We care about the true proportion of customers taking soda and not paying for it at the Slurp Shack. All right. In other words, they say, oh, we want water because it's free, and they're getting the soda and not paying for it. So that's the first thing. The next thing we need is we need the hypothesis, the conclusion for the hypothesis test. Well, let's look at that real quickly. Our null hypothesis was that it was greater than 18%, and we ended up with a p-value of 0.0070. So we rejected the null because our p-value of 0.00770 is less than 300, so we rejected. From that point, from this part right here, we can go ahead and write our conclusion. So what are we? Our p-value is 0.0070, which is less than our alpha of 0.03. Well, that information right here came straight off of our warm-up. Our p-value of 0.0070 is less than our alpha of 0.03. We reject the null. So this is what gave us that first part, those first two sentences. So there's sufficient evidence to suggest that the true population proportion of customers taking soda and not paying for it at Slurp Shack is more than 18%. I want to break this down one more time. I've been doing this every time, but I think it's really important. True population proportion and not paying for it. That right there is my parameter. True population proportion of customers taking soda and not paying for it at Slurp Shack. Exactly the same thing, word for word. That's my parameter. And then we have the more than 18%. All right. More is another way of saying greater than. And look, the proportion is greater than 18%, more than 18%. That came right off of our alternative. So this part right here is just a restatement of our alternative hypothesis. So that's our HA. For the confidence interval, well, we are 90% confident the true population proportion of customers taking soda and not paying for it at Slurp Shack lies within our interval. Well, once again, this is just a restatement of our parameter right there, which we wrote up here. Remember, that parameter is going to keep showing up, so make sure you do it well. And then the interval, we actually calculated that interval as part of the problem, and there it is. We calculated that as part of the warm-up. All right. I hope that helped. Appreciate you watching. I look forward to seeing you. Good luck on your test. Thanks. Bye.